Three cards are drawn at random from a standard deck. We want to know the probability that all the cards are hearts, the probability that all three cards are face cards, and the probability that all three cards are even. So, finding all the possible outcomes for three cards is a counting problem. We have to use the counting principle for this. And then to find the probability, we have to divide those outcomes for three hearts by all the outcomes for three cards that are any cards in the deck. So looking at the cards in a deck, 4 suits in a standard deck, clubs, spades, hearts, and diamonds. So there are 13 of each suit, so there's 13 heart cards. The probability of 3 hearts would be the outcomes for 3 hearts divided by outcomes for any 3 cards. There are 13 heart cards, so there's 13 possibilities for the first card, then only 12 for the second card, and 11 for the third card. For outcomes for 3 cards, there's 52 cards for the first card, 51 for the second, 50 for the third. So we simplify this. A fraction, 13 times 12 times 11 on the top. 52 times 51 times 50 on the bottom. That gives us 0.0129 as our probability, which matches what is here as the answer. The probability for 3 face cards, that's this one, is the outcomes for 3 face cards divided by outcomes for 3 cards. Looking at the deck again, there are 3 face cards in each suit, so there's actually 12 face cards in the whole deck. 12 possible outcomes. So there are 12 possible outcomes for the first face card, then 11 for the second card, 10 for the third card. And the total outcomes would be the same, 52 times 51 for the second card times 50 for the third card. We have a fraction, 12 times 11 times 10 on the top, 52 times 51 times 50 on the bottom, 0.00995 as our probability. So about 0.995% probability. And that matches the answer here. For the third part, we want to find the probability that all the cards are even. So it gives us some help here. It says, let aces be 1, jacks 11, queens 12, and kings to be 13. So 2 is even, 4 is even, 6 is even, 8 is even, 10 is even, and queens are considered 12, so they're even. So we have 1, 2, 3, 4, 5, 6 even cards in each suit, and there's 4 suits, so 6 times 4 would be 24 even cards. Probability of 3 even cards, outcomes for 3 even cards divided by outcomes for 3 cards equals 24 possible outcomes for the first even card, then 23, then 22, divided by 52 possible for the first card, if we're looking at all cards, times 51 times 50. a fraction with 24 times 23 times 22 on the top, and 52 times 51 times 50 on the bottom, 0.09158, or 9.2% probability, which matches the answer here, 0.09158.